Welcome, everyone. Today we're talking to Carl Curran, Humotech's Dynamo Director of Engineering, whose passion for pushing wearable robotics to the next level is totally infectious. Tune in to learn more about what makes the engineer behind the Caplex system and everything we build at Humotech tick. And now, without further ado, Carl Curran. Hey, Carl, how you doing today?
Hello.
I'm used to hearing
busy as always.
That's great.
But doing pretty well.
So you and I have worked together for a long time across quite a wide range of different robotic prosthesis and exoskeleton projects. But I want to hear it from your perspective. How did you get into this field, and what have been the highlights of the Humotech journey so far for you?
So I originally was at school for mechanical engineering and minoring in robotics. And that was all great. But I think what probably sent me down the path of doing the kind of work we do here is all the projects that I did outside of class. So there's some internships, some research assistants, working on some competitive projects, getting roped into doing more stuff because I couldn't say no. And sort of those projects ended up requiring going out into the real world and suffering the consequences that real world testing and usage has on what you've made. So in my case, I could go on for a while about the robo buggy that I did at CMU, which is great and still going. But it was the kind of work where, one, there's like a competitive spirit that like motivates you to keep doing more. And it's the kind of work where to actually get the thing working and the day that you need it to work, you've got to be constantly working with your hands, having some fail, fixing it, making it better, figuring things out, working with a bunch of other people who also kind of know what they're doing and sort of building upon that collectively. That sort of dragged me into sort of the world of mechatronics and making things work for the real world. Also some space wheels, some like fun, cool projects that I couldn't say no to. But a lot of that was stuff that I was just used mechanical engineering skills, but built upon stuff that I had to sort of learn myself to do the actual really fun stuff. It was like outside the scope of the engineering undergrad. I feel like that leads itself into how I found myself building things here at Humotech. And then also, I have a desire to make things that just work. I don't want to have to, struggle or fuss over I do, but I don't want to have to do that all the time. So doing that during undergrad, doing that during grad school, and afterwards, I forgot where I was going with that. But I think it was generally a desire to make things that work well the first time.
Sort of special interest projects. How did you find yourself walking into the biomechatronics lab?
Yeah, so I graduated back in spring of 2015, and I was the kind of student who took too many classes. And as a result, I didn't have a plan immediately after graduating. So upon graduating, I messaged a bunch of professors, asked if they were looking for any help over the summer while I applied to jobs. And one of those professors was Steve Collins, who was in undergrad. He was my Design 1 teacher. He was great. And then I took a class with him in my grad year called biomechatronics. Actually, I took that class my senior year, but I had to drop it because I was just taking too many classes my grad that year. But he put me in contact with you because I think you had said at the time you had just founded Humotech like that spring, and you had your foot, and the actuation system was fixed and bolted to a plywood table or wooden table, and it was stuck in the lab. And I had already had experience in like the second time I took the class, sort of moving the system from one building to the other for like the testing that happens with the running the studies and the 2 degree freedom foot that was built there. And so it was an opportunity to make things, use the CNC, built some parts, and a good project to tide me over for a little bit. And so that happened. Built the first actuary unit that we had. And then I think you went off to some conference and did a demo, and then immediately got questions about buying the system, which after I was out of college, I think you then emailed me or something saying like, hey, what if you just like come here and like work for a little bit longer and like make this sort of take off a bit more? And then eventually it was like, yeah, I want you to rebuild the foot. So come work for me full time. And that's how I got pulled into this
right out of the gates. It was
space.
Imperative that we started building some of the first systems. Since then, we've built, I don't know, 20 some.
We've redesigned. Yeah, go ahead. We've like designed and sold like 20 something units, devices to a variety of customers now. And I mean, that old foot I'm actually currently redesigning that now to be even better than it used to be, even with the 2 revisions that I had overseen. Now it's like, it's
I feel like continuous self-improvement is one of our kind of core values. And also, always expanding the breadth and sophistication of what we do.
For sure. It's never, I mean, good enough is good enough for getting things out the door, but it's never really good enough.
I feel like you and I are
better in some
very
aspects.
Similar in this way, but at least I try to take the time to reflect on, moments in time that I felt especially proud of what we built, acknowledging that there's still room for improvement. But I just thought maybe you could share 1 or 2 examples of systems we've built together where you felt like, wow, we really moved the needle on this one.
I mean, for me, the biggest thing that comes to mind is the work we did with the Climb, the LVA, where that was really first taking that foot and doing a big study with dozens of people at 3 different locations, and just sort of getting this feedback of, this was kind of easy. It's sort of like, that was sort of like a real tangible moment of like, this work actively saved time and allowed people to do something cool, interesting, and novel work that not only validated what we were working on, but made it clear how it could be used in a practical clinical setting and actually like help people. That's, I think, one of the more tangible events that we've had here, where I felt like a sense of pride. That, and like also like working with the researchers on the published papers and like having the authorship, which is nice, because I didn't go to school to be a PhD. I didn't go to school to like be an author, and that's like, and sort of been a natural extension of doing this work and collaborating with these researchers, is like, that can happen, and you're ensuring that it can.
Yeah, I love that we get to
it can happen.
Recognized for our contributions to some of these larger projects and kind of developments in the field. We're all about enabling others to do good work. That kind of helps me segue into my next question, which is, zooming out a bit, looking at the industry at large. I feel like we operate in a field, and most tech fields are like this, where for the engineers, it feels like there's just this huge amount of unrealized potential. If we could just solve a few major gaps, we could like enable the sci-fi dream to become a reality. Okay, so I'm curious if you could characterize for us how you see the field today and where it could be in 10 or 20 years.
Specifically like the robotics field here for biomechanics and human motion?
Yeah, I mean, robotics in general, I think, faces some great challenges, which are relevant to us. But also, where robotics meets the human, I feel like there are a lot of kind of technical challenges that we've interacted with.
Yeah.
So Yeah, I mean, it's a broad
Yeah.
question. There's sort of a million things that need to go right for us to realize the sci-fi dream. But what are the ones that, I don't know, pique your interest the
Yeah, I
most?
mean, in terms of the blockers for the field, like, there's a few things that I could talk about. I mean, I think the first roadblock in this, and maybe the most important roadblock, is just the this getting started. Because in my mind, and at least of what I've experienced with the products I have worked on out like before coming on board with Humotech, the sort of robotics. I mean, there's the whole biomechanics and like working with individuals, and that's very important. You can't do this kind of work if you don't know how to design for or work with people in terms of ensuring that one, as they're like putting it on, that they're comfortable, that it's intuitive. That's a whole like realm of design experience and interface that is, I feel like whole separate thing from like the starting point for engineering, where you're thinking like the high level hard problems. But really getting started in the robotics aspect, when you want to like put something on a person and you want it to induce motion or induce a force or something, the aspect of building wearable devices, and you can have experience with mechanical systems, components. It's not easy. It takes time. But then there's also the software and controller development side of things, which in order for things to sort of, I think, be worked on and developed faster, the gap between the people who are doing the design of the hardware and the people who are doing the design of the software controls, that needs to be bridged so that there can be a better transfer and back and forth in terms of the accessibility of all that. Because I come from this with like a very mechanical hardware background, and that's intuitive to me generally. But someone who's coming to this field from more of a CS background is going to approach the problem from like a CS perspective. And in my experience, that's been fairly, while very important, detached. It's been in my experience somewhat detached from the physical side of thing. And you can't do this work without really understanding and working with the physical side of it, whether it's the mechanical hardware, an exoskeleton, prosthetic foot, a leg, or the fact that you are not working with some fleshy meat bag. You're working with a human being who, they're sensitive, they're unique, they're squishy. And I think designing for that use case, that application, it's not straightforward. It's a challenge that you have to learn how to work for. And where was I going with this? The general theme I think I'm going with is that in robotics, and in turn the design of robotic systems that we wear, there is this artificial barrier, it feels like, with regard to robotics and programming, where it makes a lot of sense given the origin of robotics and sort of how it naturally spun out of people who were pioneering the field and like dealing with the hard technical software CS problems that people hadn't figured out yet. But I'm thinking of like people like Red Whitaker or like other, Mark Raber, people who like start out with like a world where you've got to tinker and make things work. And I didn't have a background tinkering, making things work. I learned that sort of myself. But I think that was like built into their designs of their robots. And my feeling right now in terms of what is, I'm not going on a tangent, but like my feeling.
That's good. This is what this is all about.
My feeling with like, sorry, my train of thought.
Well, I think I'll take it in a direction that may or may not be where you were thinking, but as you're talking about robotics, I'm kind of reminded of how robotics as a field sort of started within the rigid and fixed environment of the factory floor. And that's, for a while, I guess, how most roboticists were trained and where most of their experience was. And then, before you and I started getting involved, the field of field robotics was born. where people started to try and take robotics principles and apply them in unstructured, messy environments. And I know when I first got into robotics, like that's where my interest was. I loved the idea of building a robot and sending it to the moon. Or
I've heard this with friends too when they apply for jobs. They're like, "Hey, big aerospace company, what are you doing with robotics?" And like, "Oh, we're doing manufacturing." And my friends were like, "You're not going to the space and the moon?" And okay, moving on. Kind of boring.
Not boring.
But I mean, very useful and can be cool.
Not to say that those other fields are not important and relevant, but like fast forward to today in our niche where we're trying to solve big problems, like the robots are wearable and they're interfacing with the body. And by and large, when an engineer comes and interviews with us, they don't have that experience.
And it's like,
developing those kinds of systems. So the kind of education system needs to change to enable.
Yeah. And I'm thinking this in terms of the context of interviewing people and talking with people who are currently like doing this kind of work. I mean, the emphasis in robotics is very much focused on that side of things, which is more like AI, machine learning, vision, sensing, all cool stuff, all important, but it's not so much focused on the sort of practical nitty gritty of like, how do you make sure your code always works? And like, how do you make sure that's not only does it always work or works very often, but also I don't think there's really isn't emphasis at all on designing code such that it is accessible. Like you look at some of the software and code that's out there and you get started with it and you realize, I have to basically get another degree to really dive into this. And that is a bit exclusionary for anyone who's, has a great idea or has an expertise in biomedical field or some other mechanical space. But like you look at some of the robotics systems that are out there and there's just layer upon layer of abstractions. You have to fundamentally change the way that you think in order to use the tools that are used for development typically of robotic systems. And that really just feels like an artificial barrier that keeps people out. And while there is a purpose and space for that, especially when like you're going to space and every gram of computational hardware matters and you have to like emphasize optimization of stuff, you have to really compartmentalize and like make things really highly structured and capable, there's a place for that. But getting started, like I got started with Arduinos and some basic controller stuff that there's lots of tutorials online, and I blew stuff up. My code initially was not, it's not elegant, it's not the most optimized, but it works, and you can do stuff with it. You can do cool things with it. You can do development with it, and eventually, as you like progress and find the path forward, eventually you'll bring on someone who has the expertise, who has that like true breadth of knowledge with regards to software and controller developments. And there's a place for that, and that's, great. But getting started, like, and this is in part very much of my own bias, because I am very much a jack of all trades kind of engineer. If there's a problem, I'll try to learn what I can to work the problem and make it robust. So anytime like I encounter something which is overly complicated or feels like this has been around for 20 years, it shouldn't be this hard. That's a big blocker in my mind.
Yeah, I think I mean, the whole point of the Caplex system, and I'm seeing that this is a consistent theme in this podcast series. The whole point is about lowering barriers to access and kind of growing the pool of people trying to solve some of the big problems in the field. I like your example about the Arduino. I mean, I had a similar experience. I had programmed other microcontrollers before, but when I discovered the Arduino, it was like, holy cow, this is so easy. How is this?
I didn't even
this
realize
easy?
I was writing C code when I did that. I was like, oh, there's this tutorial. You follow it. It's like the path is, your hand's not being held, but like someone's showing you the path you can follow to like learn what you need to know and do what you want to do.
Yeah. So I think that's that's why we exist. And there are so many things in a wearable robotic system that the developers should not have to worry about. And to pat ourselves on the back a little bit, I feel like we've done a good job of that. It's a very complex system, but the vast majority of it is, stuff that today, the developer doesn't need to worry about. But before Humotech existed,
yeah, I mean, I think people often were making their own custom motor drivers and thinking about field-oriented control of the motor windings, and it's like, you shouldn't have to do that. If you want a motor to move, what you should be able to do is just say, okay, motor, you're at 90 degrees, move to 92 degrees. Motor, you're at 0 RPM, go to 5 RPM. Motor, apply this much torque. Mm-hmm. And at this point in time, stuff like that low-level kind of stuff should just be easy. You really shouldn't have to worry about the low-level stuff. You should worry about the high-level stuff. What's your strategy for doing this thing XYZ?
I feel like as a society, we progress by, the old cliche, standing on the shoulder of giants. It's really all about inheriting all the work of previous generations that resulted in certain things that were hard for them being easy for us. My view is that we're in a kind of generational shift with wearable robotics, where people graduating today are now used to using certain tools that for the previous generation were really inaccessible.
Yeah, that's a whole thing with robotics in general, and just sort of like people set in their ways, and you got to learn how to improve consistently all the time.
Yeah, I'm curious if you could speak to your perspective on how developing a wearable robotic system with Caplex might differ from trying to do it with a homebrewed system that, maybe built by students, or trying to hack a typical commercial product into doing something experimental.
Yeah, so this sort of follows that same theme in a lot of ways, because I think for typical development like this, traditionally you'd have like a team of people each working on some segmented portion of the system. Like you'd have like a mechanical team, you'd have an electrical team, software, controls, operations and management. And yeah, this is sort of been like as I've used the system, I want to be able to do all these things because that's just my nature. I want to be able to like be independent. I want to be able to build, say, a foot, and then I want to be able to test that foot because, well, this is my project. I want to make sure it's working. I don't want to have to, and this honestly turned me off from other potential jobs where you have a job, you do one thing, you do that one thing for the next 20, 30 years. Yeah, I want to be able to build and test some idea, some design. I want to be able to have an intern come in, give them a clear task, and then ensure that they can do it. And they don't need to like ask me for help every day. They can sort of follow the clearly defined thing and do their own stuff. So I'd say where the Caplex system differs from maybe traditional R&D, either in a lab or a traditional company, would be that it is designed with the intention that one person could do either most things or everything if they wanted to. Maybe this is sort of again, biased from like a mechanical design perspective. But there's nothing even stopping a controls or software person from having an idea, using some common interface that they can just attach to, and then trying out their own thing. The controller doesn't really, it's sort of agnostic to, are you using this particular hardware? Okay. Are you not? Okay. Update some geometry, and that's probably all I need to do. And yeah, you can sort of just have at it. That I think is a big difference for an individual rather than a team.
Some of my favorite experiences, working at Humotech have involved people with no engineering background whatsoever coming in and being able to use the controller and experiment with different things, whether they're a physical therapist or a high school student. I've been amazed at the speed at which, some people can pick it up.
With some of the demos we've had where an amputee comes in, they walk on a device, and there's a prosthetist there in the room. It's just showing them how, at a high level, what they want to do or what they can do, and enabling them to sort of actively control the system. Because, at the end of the day, my belief and philosophy is that anyone can learn anything. There's, you just need the right tools, you need the right motivation, you need the right teacher, you need the right amount of, you need enough time to do it. But yeah, if your documentation and tools are good, then it should flow, and you should be able to intuitively understand like what is being talked about, and then eventually you'll have a solid grasp of what's going on, how to change things. So like these prosthetists or clinicians who come in, use the system, you explain some concept that is simple, straightforward, and you build upon it, make it more complicated, and they can follow along and build upon it and like act on it. The whole stiffness emulation with the prosthetic foot is that kind of building upon a straightforward, simple concept, and then allowing people to understand how it can build up to affecting the prescription or clinical process for patients.
I feel like we're demystifying many aspects that previously were assumed to be only understood by experienced engineers.
Yeah, that's sort of the conundrum in a way, because like we spend all this time trying to make things easy, trying to make the design easy to digest, easy to follow along with. And once we spend a lot of time doing that, and you have that final sort of beginning template, it's hard not to have the feeling of like, this is really easy. This is really easy. What's going on? And it's somewhat deceptive, but it sort of hides all the effort that goes into ensuring by design that it is easy.
Well, I mean, that's just natural to the engineering process, I think. When you get in a car, driving a car, assuming you have a reasonable amount of training, feels very easy and natural. That doesn't mean the car is a simple thing. On the contrary, cars are incredibly complex now. But the user experience should be seamless. That I think is the dream. So looking forward, and kind of building on our successes to date, I'm curious, what are some of the big things out on the horizon in terms of usability or performance or capabilities that like you want to build in the next generation of Caplex systems?
So, I mean, at this point, I think we've generally nailed down the whole actuation of motors and components for using with a wearable device. I feel like, as we like build more stuff with the lower limb and wearables, like we're gonna just keep on adding on to the ankle, to the knee, to the hip, the back, and so on and so on. Sorry, can you repeat the question?
I think that's the start of an answer. It's just like, where do you want to take all of this? What is sort of a next frontier that you're excited about?
So I feel like what I'm excited about, there's like the novel devices we can make that people can wear and you can do more interesting things with and more complicated things with. I think what I'm excited about is a lot of the low level stuff that will enable all that more complicated stuff to be possible. So a lot of that, I mean, it's not like necessarily new stuff. It's just making sure that it is taken from the sort of hard to access state it is now, what is like signal processing communication for like large distributed systems, as an example, and ensuring that that is easy. That like you want to know what's happening at your ankle, okay. You want to know torque, position, speed, orientation, space, is the foot in contact with the ground, yada yada yada. Okay, you want to know the same thing that's happening at the knee. You want to know the same thing at the hip. You want to know the same thing on the other leg. You want to know the same thing over here, and you want to add extra sensors that were not in the original scope of work for your whatever. The like this exists. Like cars have this already implemented in a distributed network that's there. But having something that is that, but sort of plug and play for developers is the next natural thing that I think will extend the capability to allow us to keep adding more complexity, more and more capability, regardless of what people want to do.
I feel like the longer you spend in a field as an engineer, sort of this blessing and curse that you realize anything is possible, but it's not all within your grasp. So I feel like Humotech as a company, I mean, we could build and control any wearable robotic system you can think of, but there's certain things where we have a lot of experience and kind of taking the leaps in development are relatively
like we, I think,
whereas
like we, I think, are really good at the mechanism side of things. Like that's our expertise. That's like what we are good at. We can keep pushing that forward. And, you know, as we naturally want to add more mechanisms and do more things, we see where we need to bring in others or build new skill sets, whether it's like production or development or any other thing.
Yeah, and obviously it's going to take teamwork, right? So Humotech can't solve all of the problems in the field. But I think one of the things that makes us unique is that we, as individuals and as a company, are just sort of obsessed with the idea of collaboration and working, at the intersection of different disciplines. So where we may be missing a core competency, we naturally, reach for potential collaborators that, where we could realize a win-win opportunity together. I feel like we have a lot of work to do in this domain because I don't know what it is, but something about engineering training doesn't always lead you towards collaborative thinking. Maybe I'm biased. Maybe we're biased coming from the school that we came from, but I feel like there tends to be a trend towards, I can do this. I can figure this out myself. Like I don't need to ask for help.
That's I know plenty of people who are like that, but it's.
And of course you can, right? You can do anything you set your mind to, but like, is that the best way to get it done? Is that the quickest way to get it done? Probably not.
Yeah, you can't really. It's sort of setting healthy boundaries of like your scope of work to ensure that you can just like doing good work and getting things out there. But like, at some point you have to hold yourself back so you can like be reasonable. But you should always be pushing.
Yeah, and I think one of the things
is balancing. Balance is a balancing act.
Yeah, it's definitely a balance to strike. one of the ways I think about this, like kind of shifting focus a little bit to company culture, is keeping it fun. Ideally, everybody enjoys what they're doing, and certain types of responsibilities and tasks can feel like an uphill battle, even though you're fully capable of it. Maybe it's just not the thing you want to dedicate a lot of energy to. And, if you have healthy collaborators and healthy relationships, there can be an ebb and a flow where, your focus areas continue to adapt and respond to, kind of the team that you have around.
That is one reason why, doing market research, looking at what else is out there and seeing other people's work as one reason. One of the things I do like about sort of when thinking about the next thing to build, sort of looking at the papers that research labs have made, sort of they describe their capabilities, they describe their ideas and mechanisms. Oh, that's really neat. What can we build upon from that? Or this is just sort of my own personality behind it. Is what are their specs for what can they do, and can I do that better? Maybe. I mean, it's not a it is. Competition is sort of a part of it. It could be a part of it, but I don't know. My hope is that one, we sort of push boundaries of what can be done, but also can I make this the best it's ever been? And who can I reference and compare not only past design, but my system requirements document to know where should this go in the future? How can we ensure that we are not only staying relevant to people's needs or expectations, but how can we exceed people's expectations for based on what's already out there?
Yeah, I totally believe that competition and collaboration can coexist in a field, and I think they need to for that field to progress. I mean, competition gets to your innate desire to make things better and to always improve, and collaboration is essential to kind of fill the gaps in your knowledge and your capabilities and your just limits as a human being. You only have so many hours in the day, so you can't do it all.
Unfortunately.
Yeah, maybe we'll talk about that in a future podcast. But we're getting to the end of the hour, so I have two fun questions for us to close on. One is that I'm curious if you have a particular exoskeleton or wearable robotic type technology, a pipe dream of yours, that if you could snap your fingers, you had all the resources in the world, what would it be? What would you do with it? You're allowed to go totally unrealistic.
Yeah, I mean, three things that come to my mind, and maybe, I don't know if it's a new thing or just some of it's not new, but clearly in the field, motors, batteries are huge limiting factor because they weigh so much. And I mean, anytime you're adding stuff to the human body, it's you have to balance that of that balance the assistance versus the extra effort that the person has to deal with or contend with when they have all this extra stuff on them. So with motors, emphasizing the high torque density motors and trying to miniaturize that as much as possible is I remember obsessing over that a little bit for when we were first starting out. It's just looking into motors, what's out there, how is there improvements? Is anything's coming up that's better? And you see,
as a company, we've cheated with this by putting the motors off board.
So
so they don't have to carry the weight. But I still find myself wishing those motors had
I still
inertia, and those Bowden cables.
I still find myself looking up new things online, the whole Songbei Kim lab where they do all this custom development of motors, just sort of gawking at that and seeing that one master student that redesigned the motors for the mini cheetah, who's now his designs are at other companies that he took his online free stuff. And anyway, so yeah, I mean, as a fantasy thing, very super high torque density, super low weight motors for the kind of stuff we do servo motors that we kind of use. That's like one possible. That's one dream. That's like I wish that was like available and ready to access. And there's like other things too that I've like. I remember there was the whole forged carbon fiber material thing that like came out a while ago with was it Callaway and some sports car. And well, maybe this isn't a pipe dream because like now you can find good tutorials like how to do it. And this is more like a do we have time to implement this cool thing? That's sort of like what's on my mind is like I know how to do this, but I need to hold myself back from like going ham and just like trying it out whenever I can.
I'm bullish on the future of carbon fiber at Humotech.
Yeah.
Our new hip exo is pretty awesome, and I think we'll continue rolling out newer and later things.
Yeah, the whole benefit that we can get from that is making things sleeker, making them more conforming to the body, not individually conforming because that's a lot of work. Maybe they could be, but that can be extra. But like nice, slim, sleek, lightweight devices that we can really push things to the limits and allow people to have the minimum amount of extra efforts and sort of keep things out of the way of the rest of their body and sort of do new, interesting things with them. That's sort of like the fun, cool, some of the fun, cool technology that I'd like to pursue and like see. In terms of like fantasy, like technology that I'd love to, I mean, ultimately, we've talked about this in a way, but like all of our controls is like are fairly straightforward, fairly clear typically. And I know that like what people often struggle with and like are actively pursuing is understanding and being aware of like at the moment of or ahead of time of what the intention of a person is going to be. If there's like a nice, like really compact, form-fitting way of like extracting that information such that you can know what a person's going to do without mistakes, that'd be cool. But that then runs into the exact same problems that you'd have with like autonomous driving, where it's like, okay, is that practical actually? Like, you know, you can't possibly know everything that's going to happen or what everything a person's going to do. So that I think would be a really cool thing if it was like available and like someone like discovered how to determine someone's intentions in real time for all use cases. But that's a bit of a stretch.
I think we're on the cusp of, serious attention being focused on this. Given what's happening in other industries with AI, it just seems like there's huge potential to use AI algorithms to kind of model and predict human mobility. But yeah, there are some fundamental challenges that will need to be addressed. Yeah. One of which is just how do you collect all the training data? I mean, there's just a huge variety of people and activity types. And people don't want cameras rolling 24/7 analyzing their gait. I don't have the answer.
Yeah, honestly, fundamentally, it feels like it's the exact same problem that autonomous driving has with like collecting map data, doing the, getting the LiDAR out on the roads and collecting every possible square inch of road and all the other litany of problems that they have to deal with the practical side effects, or not side effects, but the practical implications of their designs, along with making sure that the low level nitty gritty is all taken care of, all the unit tests are processed and like it doesn't fail. Or at the end of the day, really what I'm saying is that people need to ensure their like systems engineering skills are good, ensuring those requirements are like very clearly defined. You have, you don't try to like go beyond like, and this is for the case like autonomy or like sensing or predicting what someone's intention is or what the world is going to be like. Because I don't know, you can't with autonomous driving, like maybe there's a cow on the road, maybe there is no road, and with the human, it's like, are they going to stub their toe? Are they going to like trip over themselves because it happens all the time? I trip all the time. And it was like, is the sidewalk kind of gnarly or or what else could possibly be out in the world that a human being could encounter?
Well, Carl, you've given me the thought that maybe someday the wearable robotics industry will consume the self-driving car industry.
Yeah, maybe.
going to keep thinking on that one. All right, Carl. So lastly, for the wearable robotics engineers in the audience, aspiring or experienced, I was wondering if you could share a call to action with us all.
So there's the competitor in me that wants to say, bring it. And like people should like push boundaries and one up each other. And there's that side of me, which, wants to like see that healthy competition and like people trying to innovate and do cool new things and force researchers to keep making new literature reviews where they have to like keep updating what's the best in the world. That's I guess maybe one call to action. The other is like to really get going in this field and do good work. You have to maybe like there's call to action and there's like advice for like how to ensure that you make good things. Because my design philosophy is very much not, I think, typical industry where like you build a thing and you test the heck out of it and you destroy it a couple dozen times or eventually you like make the thing. And it goes back and forth, back and forth. And my general design philosophy is trying to get it to varying extents, getting it right the first time. And I feel like the only way you can do that, if you can do that, that's fantastic. But the only way to really get there is with experience. Like you have to go out, learn new things, get your hands dirty with like the physical stuff, and like really expose yourself to the different realms of robotics to get a sense of not only what you can do, but like what you need to think about or bring on board to ensure that what you want to do can be done and that you can do it in the time that you set for yourself. I'm thinking mainly of like work we've done here, side projects that I keep checking on every now and then. And yeah, it's sort of the two things. One being people learn as much as you can about the field, worry about sort of the systems engineering side of things, learn about requirements and what will help you ensure that you think your things are done in a sensible way. And then the competitor in me saying we should keep improving upon our own stuff and generally just bring
it. I love it. I think to that point, we need a wearable robotics grand challenge. Maybe I'll get to work on that. And to your other point, I feel like we need something similar to the Silicon Valley cliche, fail fast and fail often, but without the hurting people and
that
building systems that totally don't work.
You fail fast, fail often. There's another phrase which is better than that. It's like fail fast, fail gracefully or something. But like, you just have to keep in mind that you are going to fail. It's going to happen. Something is not going to work. A part's going to break. Something weird is guaranteed to happen at some point. And because of that, you need to design with safety in mind from the onset. You have to do as much as you can to anticipate all the ways that something can fail and try to account for that in some way. Whether it's like monitoring, is there like a wire that's broken for your load cell? Do you see like the voltage go from 0.1 volts to 10 volts? Whoop, hold on, something weird just happened. Or like your motor like tries to move beyond what's physically allowable and like, that's weird, stop. But designing with that goal of designing for people, and that if you fail, you need to fail gracefully. Otherwise, the alternative is you hurt somebody. And you can't do that. You need to design with that in mind.
Yeah, and you have to ensure that you learn from each of these experiences.
There's a lot of little details, and you gotta get them right.
Well, thank you, Carl. the guy who knows how to get all the little details right. We appreciate you, and we appreciate everybody listening. That's it, folks. Thank you.